Okay, so let's do another example of finding all of our zeros. So this will be example 2. So we're going to find all of the zeros. So here's our problem. F of x is equal to 2/3 x to the power of 4 minus 14x over 3x cubed plus 20 over 3x squared. Okay, so the first thing that we want to do when we find all of our zeros, if you remember, we're saying that a of 0 is an x-intercept, so again, a 0 solution. So what I'm going to do is I'm going to set my equation equal to 0. So that's exactly what I'm going to do first. And the reason why I want to do that is because I want to get rid of all of the denominators of 3. So I'm going to multiply both the right side and the left side by 3, and I can do that once I set my equation equal to it. And so now this just means I'm going to be dealing with this equation. So 2x to the power of 4, 14x cubed, and then 20x squared. So now I can do a little factoring. So I'm going to factor out my GCF first. So I notice that there's a 2 in all of them. So I'll pull out a 2. And I know I have x's, so the highest is an x squared. So pull out an x squared. So I have x squared minus 7x plus 10. So I'm going to go ahead and I'm going to factor that. So 10 and negative 7. So I know that that will be 5 and 2, but they both have to be negative. So set up my area model. X squared minus 5x minus 2, and then a positive 10. So my numbers are x and x, negative 5, negative 2, perfect. So 0, and then 2x squared, x minus 5, and x minus 2. So now I'm going to set all of these values equal to 0. So I'll do that over here. So 0 is equal to 2x squared, and then 0 is equal to x minus 5, and 0 is equal to x minus 2. I'm going to get 0 is equal to x squared, take the square root. I'm going to get x is equal to 0. I'll add 5 to both sides. I'll get x is equal to 5. Add 2 to both sides. I'll get x is equal to 0. So here are all of my x's, 0, 2, and 5. These are also x-intercepts, so I can call them, so I can write them like this. I can say that it's 0, 0. I can say 2, 0, and 5, 0. Now, one thing to think about when we're solving all the zeros, what's the point of all this, right? So if we come back to the first thing that we talked about, which was our n behavior, talking about when n is odd or when n is even, right? What does kind of our graphs look like? Basically, what we want to know is where is it going to cross our x-axis and what does the n behaviors look like? So if I think about this problem right here, make a quick little sketch. 0, 0 would be right about here. 2, 0 would probably be here. 5, 0 might be right there, right? If I look at the original problem, it's even, right? So I know that it's going to be opening upward, right? And so I want to figure out kind of how am I going to go through all of these points, okay? And so if I think about it, something I got to be able to maybe go through a 0 and go through this point, and then something needs to happen here, okay? So I want to show you what this looks like on Desmos. So let's pull this up really fast. So bring this over here. So 2x to the power of 4 minus 14x cubed, cubed, and then plus 20x squared. Okay. Oh, I forgot the x on the x squared. There we go. Oop. Hold on. X squared. There we go. So I want to point out right here, notice on this graph, it actually doesn't go through the point 0, 0. It kind of looks like it bounces off of 0, 0. But it does go through the point 2 and it does go through the point 5. So if we come back to our problem, we're going to notice that on this part right here, notice that when I take the square root, I actually get two answers. So if I ever took the square root, say the square root of 4, right, if it was x squared is equal to 4, and I took the square root, it would give me x is equal to 2 and negative 2. So I get two answers. So technically, there are two answers here, 0, 0, but we don't want to write it out as two zeros, right? So it's what's known as multiplicity. Okay, so multiplicity. Right. Okay, so if we have a multiplicity of 1, so multiplicity of 1. Oh, I think I'm spelling multiplicity wrong. Hold on one second. Ooh. Let me spell this one more time. Ooh, too big. Try this again. There we go. Small. Multiplicity. There we go. Multiplicity. Okay, so if you have a multiplicity of 1, which means that your 0 is only appearing once. So 0 only appears once. What's going to happen is your graph will go through the 0. Okay, so example of what this would look like for a multiplicity. So if we have a multiplicity of 1, so if you're a multiplicity of 1, your graph's going to kind of go through your graph kind of something like this, right? Multiplicity of 1, we only see that 0 appearing once. If we have a multiplicity of 2, so multiplicity of 2, which basically means 0 appears twice. Okay, what's going to happen is your graph is going to bounce off the 0. Okay, an example kind of what that graph would look like. So if I have a multiplicity of 2 for these 2 points, maybe my graph's going to look something like this, going to bounce right off. And it's going to come back down and bounce right off, right? So multiplicity of 2. Again, we can have a combo of these multiplicities. I can have a multiplicity of 2. I can have a multiplicity of 1. And then the last type we're going to see is we're going to see the multiplicity of 3. And basically what this means is, again, your 0 appears 3 times. Okay, and your graph is going to cross through the 0. So graph crosses the 0, but it's going to cross it as a cubic. So crosses the 0 as, oops, let me write that better, as a cubic. So this one's a little bit harder to see, but let's see if I can draw it really fast. So crosses it off like a cubic. So let's pretend that these two zeros are your cubics. And so your cubics is going to almost looks like it goes flat through that point. And then it'll come up and it'll go flat through that point. So it kind of crosses it as a multiplicity of 3. So let me kind of show you. You can have a multiplicity of 4. The multiplicity of 4 also kind of look like the bounce. Basically, anytime you have an even multiplicity, it's never going to cross the 0, right? And an odd multiplicity, it will cross the 0. Okay, so let's put that into good use, and we're going to sketch this graph. So we're going to sketch the graph. Right. So f of x is equal to, and we're going to say x parentheses x minus 1 squared, x plus 3 cubed, and x plus 1. So the first thing that I want to do is I want to find my zeros. So I would set all of these equal to 0. So I'm going to get all my zeros first. So I have x is equal to 0, so this will be 0. I get x minus 1, so that would equal 1. I would get negative 3, that would make this become a 0, and I would get negative 1. Okay, I only see 0, 1, so it only has an exponent of 1, so I'll put a little 1 next to that. This x minus 1 that had a square next to it, so it would be a multiplicity of 2. This had a 3 next to it, so it would be a multiplicity of 3. This had a 1 exponent, so this will be a multiplicity of 1. So these are all your multiplicities. All right, so how do I sketch this graph? All right, I'm going to draw my y-axis and my x-axis, and I'm going to mark off, so 1, 2, 3, 4, 1, 2, 3, 4. Excellent. Okay, so I'm going to put zeros at 0, and at 1, -1, and -3. Okay, so what else do I know? Let's count up my degree. So this would be 2, 5, 6, 7. So this is a 7th degree. I have a leading coefficient that's positive. So again, if I come back over here, so it's odd, so it's going to look like one of these two graphs. Leading coefficient is positive, so it's going to look kind of like this graph. So I know that I'm going to kind of start down here and probably end up here. Okay, so I'm going to go through here. It says go through multiplicity of 3, so it's going to be like a cubic. Oops. So I'm going to make it kind of look like this. Okay, and I'll connect it to this part. And then -1 just has a multiplicity of 1, so I'm not going to go very high. I'll come right back down. Multiplicity, so 0 has a multiplicity of 1. So again, I'm going to come through this point. And then 1 has a multiplicity of 2, so it's going to bounce off of it. So bounce, and then come right back up. Okay, so again, I can connect it to the arrows that I already created, or I don't have to. Right? So if I looked at this graph on Desmos, so let's take this one away. So x, and then x minus 1 squared, x plus 3 cubed, x plus, x plus 3, and then x plus 1. Okay, so again, we can see the cubic. So I'm going to zoom in. So we can see that cubic through the -3, which is what we had. I can see it kind of goes up. We don't really know how high it goes. You're not going to learn. Look, notice that this is a relative maximum point. Notice we have another relative max point all the way up here. Come back down. We have a relative min point. So here's a relative min point down here. So again, it comes through the -1, and then it comes through 0, hits a relative minimum point or maximum point, comes back down, hits the 1, which is a relative min point, and then goes right back up. So again, here's what the actual graph looks like, and here's what our quick little sketch looks like. Notice that I didn't put any points up for the y-axis. We don't really need to know what our y-intercept is or how high or how low it goes. We will be talking about this later on when we talk more about limits. Okay, so again, we can now graph any of our old graphs. We can kind of know what's happening here. So if I come back to remaking this graph, I know that there should be a bounce right up here, and then it goes through 2, and then it goes back through 5. All right. So again, graphing and sketching polynomials.